Welcome students. So in this session we are going to see the unit 3, that is I/O interfacing. What is I/O? That is a input and a output device. Interfacing means just joining I/O with microprocessor 8086. So how to join the microprocessor and input output devices? So in this unit we are going to study different peripheral devices that going to be connected with 8086 microprocessor. Okay, let us see.
U.com.
First one, the data transfer. So before the data transfer, we must know why we need I/O device for 8086 microprocessor. In 8086 microprocessor, there is no I/O, no input, no output device. So the microprocessor is just ALU, arithmetic and logical unit. It is just processor, as like brain. So just process the instruction what we given to microprocessor. Just execute the instructions only. The microprocessor just execute the instructions. So the first two units we were studied the microprocessor architecture, addressing modes, instruction set and programming, then multiprocessor, multi-programming, I/O programming, etc. In third unit, so what are the components that going to be connected with 8086 microprocessor is in third unit. Okay, so what is the need of I/O device in microprocessor? So the microprocessor doesn't have any I/O, that is no input, no output. So if you want to connect one mouse, so we need one mouse driver along with the input output device. If you want to connect one keyboard, we must need keyboard interface along with the microprocessor. If you want to connect one display device, we need display interface with microprocessor. So any device, if you want to connect with microprocessor, you need one intermediate device, that is called peripheral device. So between the microprocessor and the external device, we have one bridge, that is called peripheral devices or I/O devices or I/O interface. So in this unit we are going to study different I/O interface, how it works and the architecture of that I/O device and different modes of I/O device. Actually the third unit is very large unit, so we are going to study so many ICs that going to be used with 8086 microprocessor. Okay, so main purpose is the data transfer, between input device and output device. So microprocessor cannot transfer the data directly to any input device or output device. So we need one intermediate device, that is called I/O interface. So the data transfer is divided into two types. One is synchronous and another one is asynchronous. So the synchronous means the peripheral are located within a same computer as CPU. So close proximity allows all states be changed at same time on common clock. So synchronous means same frequency or same clock that is used in all the devices or all the ICs or all the chips. Same clock is used. All the ICs are operated in same frequency. That is called synchronous. Asynchronous means every device operates in different frequency. Do not require that the source and destination use the same system clock. In asynchronous data transfer, a transmitter operating in one frequency, receiver operated in another one frequency, so both are not same. But synchronous means transmitter and receiver both are operated in same frequency. If the frequency is changed in synchronous system, that will affect the performance of the entire system. Okay, so these are the two types of data transfer. Then memory and I/O interfacing. As we studied in second unit, maximum mode. In maximum mode, we are using different processor, that is a system bus controller. So by using the system bus controller, we can generate different control signals: memory write command, memory read command, I/O write command, I/O read command, etc. So this memory and I/O interfacing done only in maximum mode. So the interfacing is looking like this. The blue color box indicates a memory, red color box indicates the I/O device. So all are connected like this. So all the devices are connected with address bus, data bus and control signals. So the ROM needs memory read command, RAM needs memory read command and memory write command. Keyboard needs I/O read command because keyboard is a input device. Printer is a output device, so I/O write command. RAM is read writable, so we can do read and write operations. ROM is only readable, read only memory, so we cannot write, so we are using memory read command. Okay, so according to the device capability, we are using different control signals. So that control signal control the operations of the particular integrated circuit. So along with these signals, we are using chip select also, that is used to enable or disable the chip. Okay, this is a memory and I/O interfacing. So interface memory, that is a RAM, ROM, EEPROM, I/O devices to 886 microprocessor. Several memory chip or I/O device can connect to microprocessor. An address decoding circuit is used to select the record I/O device or memory chip. Address decoding circuit or control bus controller that is used to select the different chip by using chip select signal. Then this is an important 2 mark question. What are the difference between I/O mapped and memory mapped? I/O mapped, what is I/O mapped, what is memory mapped? What is mapping? That is a mapping means linking. Okay, map we know. So I/O is treated as a memory. In memory map, I/O is considered as a memory. In I/O map, I/O is considered as a I/O only. In memory map I/O, 16-bit addressing is used. In I/O map I/O, 8-bit addressing is used. More decoder hardware needed in memory mapped I/O, less decoded hardware needed in I/O mapped I/O. Can address 2 power 16. What is 16? That is a 16-bit addressing. So the address bus is 16-bit. So we can address 2 power 16, that is equal to 64 kilobytes location. But here it is only 8-bit addressing, so we can address 256 bytes only. or 256 locations only. Less memory is available. Here whole memory address space is available. Okay, so these are the difference between memory mapped IO and IO mapped IO. So how the memory is mapped as IO, how IO is mapped as IO. Okay, that is a important question. Next one, memory mapped IO, IO mapped IO, the points are continuing again. So the memory instructions are used in memory mapped IO. Here the special instructions are used like in and out. Then memory control signals are used. Here special control signals are used. Arithmetic and logical operations can be performed on data. Arithmetic and logical operations cannot be performed on data. So here in memory map IO, the arithmetic and logical operations can be done over data because the data are present in memory, but in IO mode that operation cannot be done over IO. So direct transfer between register and IO, data transfer between accumulator and IO. So these are the important difference between the memory mapped IO and IO mapped IO. Okay, so next we are going to see the parallel communication interface. So this is the first IC we are going to study in unit 3, that is Intel 8255. So what is the use of this IC? So microprocessor, already we told, that can perform the instruction execution. So microprocessor execute the instructions, read the instruction, read the data and execute the instruction and process the output that is stored in memory. Okay, so microprocessor just perform the instruction execution and data read, data write operations. So if you want to connect any device with microprocessor, it is not possible, impossible, without any interfacing ICs. So microprocessor not having any communication port. It has address bus, data bus and control bus. So we cannot use this bus to connect external device. If you want to connect on pen drive with microprocessor, so we cannot connect the pen drive with the microprocessor. Sorry, excuse me. So we are using on a USB driver that get the information or interchange the information between microprocessor and pen drive. Okay, so similar way the parallel communication interface is 8255 is parallel port, so that is connected with the 8086 microprocessor. So this parallel port microprocessor, parallel port IC is mainly used to connect external device parallel manner. So nowadays in our laptop or in our desktop computer we cannot see the parallel port. The parallel port is gone because the parallel port needs more wires. The wire thickness is more, it has large number of connections, toughest connection and costliest. Okay, the best example of parallel port interface is dot matrix printer. Dot matrix printer port is fully parallel port. What is parallel port? What is serial port? Parallel port means if you have a data line, 32 data line means it has 32 separate lines. So the data are transferred byte by byte in a single line. That is a parallel port. If it is a serial port means the data are transferred one by one between the two lines. Only we need two lines. So nowadays computer hardware such as hard disk and the motherboard, these two are connected by using SATA cable, SATA cable. So that is a high speed serial communication interface, very smaller cable. So 20 years back the computer hard disk and DVD drive, these two are connected with motherboard by using ribbon cable, that is called parallel cables. Okay, so the parallel cables needs number of lines, so every line is very important. If any one line is disconnected or removed or cut, then the entire process will affect. Okay, so the parallel port is currently we are not using. Okay, but in the beginning they are used the parallel port only, so that the most of the dot matrix printer, the old device dot matrix printers, then the old monitor, black and white monitors, these are having very big adapter. Okay, right, so that is a parallel cable. So here we are going to see the parallel communication interface. So this interface that is used to connect external device in parallel form with 886 microprocessor. So 8255 chip is also called as programmable peripheral interface. What is programmable? Programmable means we can program, we can change the property by using instructions. Peripheral means surrounding devices interface, programmable surrounding interface. So this IC that is used to connect surrounding input output device by using program. Okay, the 8255 is designed for use with Intel 8-bit or 16-bit and higher capability microprocessors. This 8255 is mainly designed to communicate or connect with 8-bit or 16-bit or high capability Intel microprocessors. The 8255 is a 40-pin integrated circuit designed to perform variety of interfaces functions in computer environment. It is flexible and economical. Okay, so in old motherboard we can see this 8255 parallel peripheral interface IC. So this is a pin diagram. So the pin diagram shows the different ports. Actually port A, port B and port C, 3 different ports are there. So each port having 8-bit, so that is a 8-bit line. Then 8-bit data lines are present. Okay, we are having a 8-bit data line and some control signal, read control signal, write control signal, then reset, then chip select, then A0, A1 address lines. So these are the some control signals used with 8255 integrated circuit. Okay, right. This is a signal diagram of 8255. So the 8255 consists of 3 8-bit port. So port A, port B and port C. The port C is divided into 2 4-bit port. Port C lower, port C upper. Port C lower is 0 to 3, port C upper from 4 to 7. So and V-CSE and ground, these are the power supply. In right hand side we are having a port and power supply. In left hand side we are having the data lines. Data lines are 8-bit data lines, so D0 to D7. Then chip select logic, chip select signal. So the chip select signal, that is input coming from microprocessor, that is used to enable or disable this IC. Then reset, if we are giving a reset, then 8255 set into default state. If it is has any data, then that data everything is lost, it is come to default state. All the registers and control words are reset to default level. Then A1 and A0, that is used to control the some operations, that is a lower address line. Okay, right. Then read and write is a 2 control signals, that is used to perform read write operations in internal register of 8255. Okay, so this is signals of 8255. Then next we are going to see programmable input output or programmable peripheral interface. So it has 24 input or output lines because it has 3 ports, each port having 8 lines, so 3 cross 8, 24 input or output lines which may be individually programmed. So the lines are individually programmed. So two groups are there. Okay, that is we are considered group A and group B. So group A consists of port A and port C upper. Group B consists of port B and port C lower. The port C and the port C lower and upper, that is divided into 4-bit port, that is combined with the port A and port B, that is called group A and group B. 3 ports, each port has 8-bit. So port A lines are identified by symbols PA0, PA7. Port B lines, that is PP0 to P7. Port C lines are identified port C, PC0 to PC7. Okay, port C upper and port C lower, we know that's a lower is 0 to 3, upper is 4 to 7. So this way the ports are divided into 8 to 55. So simply we can say that the 8 to 55 has 24 IO lines, input output lines. So we can control individual input output line. That is an important point. So we can control individual input output line by using program. Okay. Then D0 to D7 is a data input output lines. So these data lines are used to transfer the information from processor to peripheral device and a external device to processor. So this is a 8-bit port. Then CS bar, that is a chip select. If this line is logical 0, the microprocessor can read and write to the 8 to 55. CS equal to 0 means the 8 to 55 is enabled, so microprocessor can perform read and write operations. Reset is the reset pin. It is a signal. The 8 to 55 is placed into reset state if its input line is logical 1. So if it is reset is enabled, the registers, all the registers are cleared and it is set into default level. Then read or D bar, this is the input line, so that is used to read the signal. So microprocessor should be low to indicate the read operation to 8 to 55. So it is an input coming from microprocessor. Similarly, write is also input that is driven by the microprocessor. So here the upper line, the bar indicates that is active low. Active low means it will enable if you are applying 0, it will disable if you are applying logical 1. So these are the read and write operations. Then A0 comma A1, these two lines are address lines as act as input lines, and it is driven by the microprocessor, that is for some several operations. So this is a control logic, how the ports are selected. So CS is a chip select signal, master chip select signal. It should be always 0, then only the particular IC will enabled or it is working. A0 and A1 is a specify one of the two IO port, so that is used to indicate the IO port. The A1 and A0 is 0 means port A is selected, 01 means port B is selected, 10 means port C is selected, 11 means control word register is selected. So if you select the control word register, we can program the 8 to 55 by using the control word register. If C is equal to 1 means the 8 to 55 is not selected, completely disabled. Okay, so that is a chip select logic. Then this is a block diagram of 8 to 55A. So here it consists of 7-8 blocks. Okay, so first one we are going to see the data bus buffer. The data bus buffer, that is data bus is connected with this buffer. This buffer connect the internal 8-bit data bus of 8 to 55 Data bus buffer is a tri-state logic, so it is used to transfer the data between external device and microprocessor. It is a 8-bit. Second one is a read-write control logic. So this is a control block. So by using this control block, the entire IC is controlled by using the commands coming from microprocessor. So the commands, that is read, write, reset, chip select, these are the signals coming from microprocessor as an input, that is given to read-write control logic. The read-write control logic control the entire blocks in the 8255. The next one, already as we studied in the previous slides, that is a group A and group B. So group A is a port A and port C upper, group B is a port B and port C lower. So this group A control, that is used to control the group A, that means port A and port C upper. Group B control, that is used to control the port B and port C lower. So the next fourth blocks are, that is a group port, external port. So actually totally 24 lines are here, 24 separate input lines are present. So these lines are act as a input or output. So according to the program, these lines are enabled or disabled. Then block diagram explanation, the architecture explanation. It has 4 major blocks: data bus buffer, read-write control logic, and then group A, group B control, then port A, port B, port C. Data bus buffer. So this is a tri-state bidirectional buffer used in the interface that 8255 to system data bus. Data is transmitted or received by the buffer on execution of input or output instruction by CPU. Data bus buffer, that is a buffer is to transfer the data in bidirectional manner. Then read-write control logic. This unit accepts the control signals read, write, and also input from address bus and issues the command to individual group of control blocks, group A and group B control. So it has the following pins: chip select, then read, write, reset, A1, A0. This is the read-write control logic. Then group A and group B control. These blocks are receive the control from CPU and issue the commands to their respective port. So group A is a port A and port C upper, group B is a port B and port C lower. Then next we want to see the individual port. First one, port A. So this has a 8-bit latched buffered output and 8-bit input latch. It can be programmed in 3 modes: mode 0, mode 1, mode 2. So port A is a 8-bit. It is a latched or buffered output and latched input. Okay, output or buffered, input or latched. Okay, what is latch, what is buffer? So latch means we are having a lock to transfer the data between one side to another side. In buffer means there is a no conditions. So if they give an input, then it will produce a output. So just getting and giving. Latch is getting then giving under control. Okay, so here the 8-bit latched output or latched inputs are buffered. Okay, so it can be programmed in 3 modes: mode 0, mode 1, mode 2. Then port B can be programmed in mode 0 and mode 1. Port C it can be programmed in mode 0. Okay, these are the different port used in 8255. Next one, that is a very important diagram, important 2-mark question. That is a control word register, CWR. What is control word register? So the entire control word or entire control is come under single 8-bit number. So simply we can control the 8255 by using that single 8-digit number. So that is control word. So by using a 8-digit number, we can control the entire operation of the 8255. So how it is operates? It is just like a number log. Okay, so in number log, if the number is matched, then it will open, otherwise the number log does not open. Same way, here we are having the different number. All the individual bits are yes or no, that means 1 or 0. Okay, according to the requirement, we can fill the number in this concern cell, and we can make a 8-bit number. That 8-bit number is loaded into 8255 register. After loading that number, the automatically 8255 executing in the particular mode. First one, the first bit is D0. D0. What are the function assigned to D0? The D0 may be two options. One is 1 and another one is 0. If it is 1, then act as a input. The port C lower is defined for D0. So D0 is defined for port C lower. So D0 equal to 1 means the port C lower is a input, 0 means port C lower is a output. Similarly, D1 is dedicated for port B. D1. So the D1 is dedicated for port B. If it is 1 means that is a input. If it is 0 means that is a port B is output. And the D2 is dedicated for mode selection. So this is mode 0. If it is 0 means mode 0, 1 means mode 1. So this is a group B, very small. Group A is allocated in 3 digits numbers, D0, D1, D2. So if it is 1 means input, 0 means output, very simple. Next one is the group A. So the D3 is dedicated for port C upper. The port C upper is 1 means it is act as a input, 0 means that is act as a output. Then D4 is dedicated to port A. So if it is D4 equal to 1 means the port A is a input, D4 is 0 means port A is a output. Then D5 and D6 is used for group A mode selection, because it has 3 modes, so that we assigned 2 number, that is D5 and D6. If it is 0 0 means mode 0, 0 1 means mode 1, 1x means mode 2. That means D6 is 1 and D5 is don't care, so that is mode 2. Okay, and the last bit, that is a D7, is a mode set flag, that is 1 means active, 0 means the entire block is deactivated, that is no operations. Okay, so this is a control word register CWR. So very important 2 mark question. Okay, right? So most of the university examination, and they are asked to draw this control word register of 8255. Okay, right. Next one is the modes of operations of 8255. So 8255 has 2 major mode. One is BitSet reset mode and another one is a IO mode. So BitSet reset mode is a very single mode, and IO mode is again classified into 3 types, that is a mode 0, mode 1 and mode 2. First one we are going to see BitSet and reset mode. So what is BitSet? So in BitSet and reset mode, BSR mode, so this is a control word register for BitSet and reset mode. So here the D0 is allocated for set or reset. If it is 1 means set, if it is 0 means reset. D1, D2, D3 is to control port C bits, port C bit, and D4, D5, D6 is considered as a don't care, and D7 is always 0 for BitSet reset mode and 1 for IO mode. Okay, D7 is 0 means that is a BitSet mode, and 1 means that is a IO mode. Okay, so D0 is mainly for set and reset, and D1, D2, D3 is mainly for port C bit select. Okay, how the D1, D2, D3 operate, let us see. So in D1, D2, D3 there is a bit 1, bit 2, bit 3, so 3 bits. So totally we are having a 8 different division. So 8 division means we can individually enable or disable port C by using BitSet reset mode. In BitSet reset mode, mainly designed for port C, it is dedicated for port C, and IO mode is not dedicated for port C. So port C is enabled or disabled only in BitSet reset mode. So by using the BitSet reset mode, we can enable and disable single line of port C. So simple example, if you can having on LED, the positive terminal of the LED is connected with the port Z0 and negative terminal is connected to the ground, then we can send the data, that is 000 means port C0 is enabled. It is set to 1, then the particular LED will glow. If it is 0 means the LED will switch off. Okay, right? So similar way we can control individual 8-bit port of 8-bit lines of port C. Next one we are going to see the IO mode. So the IO mode is again divided into 3 types, that is mode 1, mode 2, mode 0, and the port A and port B are used as a simple IO port. Port C acts as a 4-bit port. In BSR mode, the port C is a 8-bit port, that is a IO port, but in IO mode the port A and port B used as a IO. Port C is used as a handshake signal, that is used to transfer the handshake signal between the devices. So port C is again divided into two types, that is a port C lower and port C upper. The features of IO mode: outputs are latched, inputs are not latched. Okay, outputs are locked, inputs are not locked. Okay, ports do not have handshake or interrupt capability. Okay, both do not have handshake or interrupt capability. So in IO mode, the mode 0 is simple input output. Where this is a features of simple input output. So this is the IO mode 0. So all the ports are output. Okay, port A is output, port B upper is output, port C lower is output, and port B is an output. Similarly, all are input port. Okay, port A and port C act as a output, and port B act as an input. Okay, right? So this way we can connect the device. So if you want to connect one keyboard with microprocessor, means we have to use the 8255 as which mode? Input mode. Okay, port A, okay, act as a output here in a second thing. Okay, right? So input mode, so port B is act as a input, so we can connect the keyboard in port B. Okay, then next one is a mode 1. So mode 1, that is a input output with handshake signal. Input and output with handshake signal. The handshake signals are exchanged between microprocessor unit and peripherals. Okay, that is used to acknowledge and confirmation of some data transfer. Okay, so features of mode 1 is port A and port B used as a simple IO. Each port uses 3 lines from port C as a handshake signal transfer. So port A and port B is normal input output port. Port C acts as a signal port, handshake signal port. For input and output data are latched. Interrupt logic is supported in mode 1. So this is a mode 1 diagram. Actually this mode 1 is input configuration. In mode 1 in input configuration, so here the port A is act as a input, and port B is also act as a input. So this is a port group A. The port C upper and port A is combined, that is called group A. So port C for port C I think 1. So these are STP, then IPF, then INTR. These are the handshaking signals. So STP is the input, IBF is the output, INTR is the output. So STP means strobed input, IPF means input buffer fill, INTR means interrupt request. Okay, so these are the different handshaking signal that is used with input configuration in group A. Similarly, in group B we are using different handshaking signals same as to group A. Okay, that is STB, then IBF, then INTR. Okay, so these are the different handshaking signal that is used in communication with the microprocessor unit and the external device. So this is the input device. Similarly, the output with handshaking signal, port A and port B is act as an output. So according to the output, the control signals are changed, handshaking signals are changed. That is output buffer fill, acknowledge, interrupt request. Similarly, output buffer fill, acknowledge, interrupt request for group A and group B control. Okay, so this is the output with handshake signals. Next one, the last is a mode 2, that is a bidirectional data transfer. So mode 1 and mode 2 is a single direction, whether it is act as an input or it is act as an output. But in mode 2 is a bidirectional data transfer. So the mode 2 is mainly used is in applications such as data transfer between two computers. So bidirectional is very important. Okay, features of mode 2: port A can be configured as a bidirectional port, port B in mode 0 or mode 1. So port A only bidirectional, port B is whether it is an input or it is an output. Port A uses 5 signals from port C as handshake signal for data transfer. Remaining 3 signals from port C is used as a simple input or handshake for port B. Okay, so these are some features of mode 2. Port A only act as a bidirectional, port B act as a input or output, port C act as a handshaking signal. 3 pins only in port C is free, that is act as a basic input or output or handshaking signal to port B. Okay, this is a bidirectional data transfer. So this is the circuit diagram of bidirectional data transfer. Here port A is a output bidirectional. Bidirectional means we are having arrow in both the directions. Okay, right. Then port C is a interrupt request. Then port C7 is a output buffer fill. Port C6 is acknowledge. Then port C4 is a stopped input. Then port C5 is a input buffer fill, and then port C that means 0 and 2 is act as a symbol IO. So this is a bidirectional data transfer in mode 2, that is a IO mode, mode 2. Okay, right. So these are the different modes of 8255 integrated circuit. Okay, right. Next one, we can see the simple program, how to program 8255. So we can see some simple examples. Write a program to initialize 8255 to configuration as below. Okay, assume the address of control word register as 23. Control word register address is 23. Just assume port A is output with handshake, port B is a input with handshake, port C lower is output, port C upper is a input. Okay, so this is the given data. Okay, next we are going to develop the control signal by using control word register. Actually we were studied in a control word register in a previous slide. Okay, so according to that control word, actually it's very slow, so we can develop the code or 8-digit number or 8-digit data that is act as a control signal. Okay, right. So these are the given data. So port A is output, port B is input, port C L is lower is output, port C upper is input. So these are the condition. According to that condition, so we can fill the control word register. This is a control word register. So control word register is in a previous slide we studied. So this is the output, these are the input, this is a mode, and similarly this is a input, this is output, this is 01 means mode 1, then this is a IO mode. Okay, right. So according to the control word format, so we can fill the data based on the requirement. So the 8-bit number is called as AA in hexadecimal form. So controller register address is 23 already given in the program, our problem. So move immediately A to AEH. Okay, so AEH is loaded into A register, then after that out 23. So we are sending that AA to controller register. So controller register loaded AE, then the 8255 operates as based on the control word given in the control word register. Okay, next one, find the control word for the following arrangement of 8255. Port is output, port B is output, port C upper is also output, port C lower is also output. So all the ports are output ports. So all the ports are output port, means 0 0 and 0 0 0. All the ports are output port. So here last D7 is a 1 because it is a IO mode. So the data is 80. So 80 means all the port are output port. Okay, the controller register for the above port of Intel 8255 is 80H. Then find the controller for the arrangement of the port of 8255 in mode 0 operation. Mode 0 operation means these two are mode. Okay, so this is a mode 0, and similarly these two bits are used to identify the mode 0. Okay, right, here all the ports are input port. So input port, input. So logic 1 indicates the input, all are in mode 0. So what happened, the result is 9B. So the controller register for the above port of Intel 8255 is 9B. Okay, for the description, all the port is considered as input port in mode 0. Okay, right. So this way we can program the 8255 integrated circuit. Okay, so according to university question, so we can find the question like this in 8255. Draw the block diagram of 8255 and explain the modes of operation. Then what is PPI? Explain the modes of PPI with neat circuit diagrams. What is the need for 8255? Draw the control word register of 8255. Okay, right. So these are the different questions that was asked from university question, okay, in the previous semester examinations. Okay, right. The 8255 is a very important topic in third unit. So most of the questions they are asking the 8255. So students study well. Actually the third unit is somewhat larger unit, so we will study different IC block diagrams and modes and controller register. So this is the format. This is a 8255 is a format. First one is a block diagram explanation, then control word. Okay, then control word format, then programming. Okay, so this way we can study remaining peripheral interface ICs. Okay, so actually these are the ICs are used to connect external device with microprocessor. Okay, it is act as a bridge. Okay, so thank you friends, thanks for watching. Please do subscribe, like and share this video to your friends. Okay, thank you so much.